Hello, my name is Elif Aklan and I'm the project manager and we are group number 12. In this project we are asked to mine Chrome repository. First of all, we chose Ninja repository in the Chrome project and we chose also specific time that you ask in the project document file. And as you see here, we chose Ninja repository and we used Git bash to extract Ninja folder, and Git clone is for extracting all necessary files, and we used git log commands. For example, here git log -p -pretty fuller, which provide us very good formats in txt file. And also we chose the time period, which is 4 weeks, just after this date. And the creation is in this way we realized. And the txt file is logrov.txt. And with this command, git log -p is a part of the command, and we will commit message, author, date, and actual change placed in each commit can be realized. And also -pretty, we change the log output to formats other than the default, as actually we can see on git bash command line. And also -merge flag also shows the changes that have not been merged yet to any branch. First of all, when we used git log -p, we had all details and information in this txt file, as you see here, and author name, author date, and author's email address, and the date that he committed, and all other details here. Some deletion on readme file, some insertion on readme file, and so on. And also we used git short log commands, which shows us in this txt file the all developers in the time range that we chose, and the developer number is 10 in our Ninja repository. And it shows here the number commit that Scott Graham has, 14, and Nico Weber has 8, for example. And this is in the order, as you see, which is really useful comment. And also, for example, if you want to observe, the last 2 commit that author has, we use -merge -2, and which gives just only 2 commands the authors have here, readme and one file changed. And also stat is also really useful key here. One file changed, it shows, and in this file one insertion he made and one deletion he made. Also, actually the most important part was the implementation parts, and we used C++ programming languages. And after extracting useful data with using git log commands, and we have the implementation parts that's benefiting from the txt file that we get after git log commands. So in implementation parts, five steps that we followed: creation of class structure, identification of top developers, float representation of developers, creation of file developer matrix, and creation of graph as a result. After data extraction, as I said, in order to processing the data, which is created by git log scripts, we used object-oriented approach, class structure actually. And in class structure, we have 2 classes, and which has the relation 1 to n. One author may have more than 1 commit, but 1 commit can belong to only 1 author. And these are the details in our structure. And also, author class represents the developer who creates several commits. commit class represents commit which is created by a developer as well. A commit has following attributes which are commit ID, commit date, commit info, and which files changed. And in which files changed we have, actually this is the array of files which is changed in a commit. And all details are here as you see. In creation of class structure, also in data extraction part, log of commits which are at the directory in Ninja repository, and we exported, as I said before, to log_row_some.txt file. And for example, in our last txt file, after using git log commands, we have here the commit ID here, and the name of author, and the date of the commit, and some notes that he made. And also these lines here represents the files which are changed by previous developers' commits. It's the relation. And while reading file, I said that we did C++ implementation, object-oriented approach. So after reading file, commit objects and author objects are created, as you see. For example, ID is here, date, commit info, and what is the file, for example, for Frederick Medley that he changed is hashmap_h. For plotting the distribution of commits in terms of each developer, we use MATLAB tool, and by using following git script, it's possible to know number of commits of each developer, as actually I mentioned just in the previous slides. And also our representation, plot representation, after implementing it in MATLAB, we have, as I said, 10 developers. So Scott has the highest number of commits, which is 14. Nico has 8, and as you see the rest. And the last, Brad, Evan, Lindley, Mike, and Peter has the number 1 of commits. And identification of the top developers. By using the log_row2.txt file, which is created by git scripts as well, and top developers who make 80% of commits can be easily determined. For calculation, identify top developers function is used. The 80 of commits, the total commits, only 4 authors provide. So in this part, creation of matrix, in this part, it's asked to create a matrix. In each row represent files and columns represent developers, which has the size 30:10. For this purpose, after log_row_some.txt file is created, code CPP file is run and matrix is created by using create matrix function as well. And here's the matrix. Matrix has 30:10 size. So the output matrix has 10 columns and 30 rows, and there are 10 developers selected from directory, and there are 30 files which are changed by developers in selected directory. And the index at ix in matrix is 1. Here for example, and here. It indicates the file I is committed by a developer J. And the index at ig in matrix is, if it's 0, it indicates the file is not committed by developer J. And as a last step in graph representation, to create graph, the matrix is used, which is extracted before. And also, from this matrix, it's easily seen that the developers who change the same file. This is the adjacency matrix actually, and it has 10:10 size, and each rows and each columns has the author's name. For example, first author Peter, and again, for example, the 8th author, they changed together, they changed one file in common. And also, these are the costs. And when you see 2 here, for example, the 3rd author and the 5th author changed 2 files in common. Yeah, and we used social network visualizer to visualize our author situation and relation. Here, first author is Peter, and the base author is Ivan. And they changed one file in common. And also, you can see here, third author and the ninth author. They changed more than one file together. And it's not exactly can be seen, but the real, if you look at it like clearly, you can see that a bit thicker than the others, for example, than this. And it means that they are changing same file together more than one file. I mean, comparing to the, for example, this one. And also, we did the same graph representation in MATLAB because we used for plotting MATLAB, and we also wanted to use for graph representation as well. So here is our last representation in MATLAB. Thank you.